Scaffold Blazor CRUD pages from a model class. We'll be using Visual Studio with .NET 8 and a local SQL Server Express database. If you don't have SQL Server Express, you can install it for free from the official site. In part 1 of the video, we'll create a model, scaffold its CRUD pages, and create a data context class. We'll make some changes to the connection string, then create a migration and update the database. In part 2, we'll create a repository class to replace using the data context directly in the Blazor pages. Create a new Blazor Web App. Select .NET 8 for the framework and set the render mode to server. Select per page or component interactivity. First, we'll add a models folder for our model or entity classes. We add a class to the models folder and call it user. Our user model will have a unique ID, a first name, last name, and date of birth. That's all we need to start scaffolding our Blazor CRUD pages. Right-click the project and select Add New Scaffolded Item. Select Razor Components and select the Razor Components using Entity Framework. In the wizard pop-up, select CRUD for the template and select the user model from the drop-down list. At this point, we don't have a data context, so click the plus. For simplicity, we'll shorten the context name to data context, but you can keep the default name or call it whatever you need. It will start installing all the NuGet packages it requires, like the Quick Grid component, the Entity Framework tools, and SQL Server package. Then it starts generating the scaffolded code for our user entity. Once done, in the Components folder, under Pages, it created a new User Pages folder that contains all the CRUD interface pages to manage our users. The scaffolding also created a data folder with a data context class. In here, we see one dataset for our user entity. In the app settings JSON file, it added a connection string to our local SQL server and gave the database some random unique name. At this point, the database doesn't exist yet, so we can change its name to something more meaningful. We also changed the connection string name to default connection. Of course, you can name this whatever you like. In the program CS file, the DB context factory was added with the original connection string name. You'll need to update it with the new name if you changed it in the app settings file. Now we're ready to create our database. To create our database, we first need to add a migration that says how your database must be created. Right-click Connected Services in your project and select Manage Connected Services. Your local SQL server should be listed with a status of connected. Click the ellipses and select Add Migration. We'll name our first migration Initial. Once it finds the data context object in your project, click Finish. Your migration is created in a new migration folder. The migration file specifies the changes you want to make to your database. It has an up method that specifies the changes to make and a down method for when you want to reverse the changes. In this case, the up method will create a user table with the ID column as an auto-incremented primary key. We're ready to update our database. Right-click Connected Services and select Manage Connected Services. With the connected SQL Server, click the ellipses and select Update Database. The dialog will retrieve the data context object and the latest migration file. Select your data context and click Finish. The database is updated with the latest migration. In this case, the user table will be created. Let's run this app. It opens with the default template stuff, but as you can see, there's no menu item for our users page yet. We'll fix that shortly. In the meantime, in the search bar on top, add a / and users to the URL. Users is the name of the path to our user pages where it loads the index page by default. Once the index page loads, it will display a list of our users in the database. At this point, there's nothing, so let's click the Create New link. This routes us to the Create page. Notice the URL in the search bar changed to users/create. We add some data for the first name and last name, and in the date of birth field, we can click the little calendar icon to select a date. But what is annoying here is the date starts at year 1. We'll fix that as well in code. Click the Create button to add the record and take you back to the index page. With our one record added, we can now see Edit, Details, and Delete links next to it. We'll click the Edit link first, and we're taken to the Edit page. Notice in the search bar, the query string now contains the ID value of the record we're editing. Change some fields, and click the Save button to return to the index list. Next, we'll go to the Details page. This simply shows the details for user with ID 1. This is a good place to display more properties of a record than you show in the index list. Back to the list, we've added another user for demonstration and click its Delete link. On the Delete page, we can see in the query string of the URL that user with ID 2 is loaded. The Delete page acts as a confirmation page. It asks, are you sure you want to delete this? Click the Delete button to delete the user and go back to the index list. The user was deleted. So our CRUD pages are working, but there's obviously some customization needed. For example, a menu item, better page and column headings, and fixing the initial date displayed for the date of birth field on the Create page. First, let's add a menu item for the Users page. In the Components Layout folder, open the Nav Menu Razor page. In line 3, we clean up the app name a bit. For the nav links, leave the link for Home and remove the rest. Then add a link for the Users page with the href set to Users and the display text set to Users. Now there's a Users link in our menu. Next, in the index page of our user pages, we change the page title and heading and add proper titles to the columns in the grid. The page title displays in the tab, and our heading and column titles are changed. For the Create page, we also change the page title and heading and correct the labels for our input fields. In the Code section where we instantiate a new user object, we initialize the date of birth field to the current date value. There's another issue with our CRUD pages. They use the data context directly in the user interface. This is not ideal. For a better architecture, it is best to use a service or repository to deal with the data access functions. This makes it easier to maintain your data access functions in one place, especially if you're going to call API endpoints, etc. Let's create a repository for the user class. We'll add a folder called Repositories. We add a class called User Repository. To be able to inject the repository into our pages, we'll add an interface for the user repository. Our interface will have the standard CRUD methods. The create method takes a user object to add to the database. The first read method will return a list with all the users, and the second read method will return one user with the given ID. Then the update method takes a user object to update and return a true or false if successful. And lastly, the delete method will take the ID of the user to delete and return a true or false if successful. In the user repository class, we inherit from the iUser repository interface. We create a private read-only data context object, and in the constructor, we use the injected data context and assign it to the read-only class variable. Now we can implement our CRUD methods using the data context. Just a quick note, while we didn't do it here, it's convention to end asynchronous method names with the word async. The create method uses the user entity's add method to insert the user into the database, then calls the data context save changes method to apply the changes. The first read method simply converts the users to a list and returns it. The second read method calls the first or default method to get a user with a matching ID. The update method uses a try-catch block to check for update concurrency exceptions. This can occur if someone else updated the user record after you last read it and then try to update it. In the try block, we first check if the user already exists by calling the any method. This will return true or false. If it doesn't exist, we return false. Otherwise, we set the state of the record as modified and save the changes. The delete method first gets the user with the specified ID. Then, if it exists, it calls the remove method on the user entity and save the changes. With our repository done, we need to make our application aware of this service so we can inject it into our Razor pages. In the program CS file, we add a scoped service with our repository's interface and class. Now let's change our user pages to use our new repository instead of the data context. We'll start at the index page. Comment out or remove the context factory injection and inject the user repository interface. We called it _service. In the code section, we'll create an iQueryable users list and use it in our quick grid. On line 36, we changed the onInitialize method to an async method and call our repository's read method to get a list of users. Then we simply convert it to a queryable list. Next, in the edit page, remove the data context stuff again and inject the user repository interface. In the onInitialized method, use the repository to get the user with the specified ID. In the update method, we changed the try-catch block when we're calling the repository's update method to catch any concurrency exceptions. You can comment out or remove any other data context-related code. In the details page, we do our user repository injection again, and in the onInitialized method, we call the repository's read method with the user's ID. Again, in the details page, we inject the repository and remove the data context stuff. We call the repository's read method in the onInitialized method and its delete method with the user ID in the delete user method. Finally, we change the create page to use the repository and call the repository's create method in the add user method. As you may have noticed, using a repository or service makes the code in your Razor pages simpler. Also, you can now inject your user repository into other pages that need access to user data. With all these changes, let's see if our app still works. Our index page still works. Let's try edit. That seems to work. Let's create a new user. The details, that still works. And finally, the delete page. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.